I would like to introduce our research titled Vendor Selection in the Wake of Data Breaches, a longitudinal study, co-authored by Qian Wang from the University of Macau, Shen Yangjiang from Tongji University, Waiting Eric Ngai from the Hong Kong Polytechnic University, and Baofeng Huo from Zhejiang University. Firstly, let's delve into the background of the study. Outsourcing is a prevalent strategy for many companies today, yet it comes with inherent cybersecurity risks. Cybersecurity is now recognized as a crucial factor in the outsourcing environment. According to a study by Vendor Risk Management in 2019, 9% of data breaches originate from third-party vendors, and this number is expected to grow with the increasing interconnectedness of global supply chains. While past literature has focused on various decision factors in vendor selection, such as cost, vendor's efficiency, collaboration history, and professional capabilities, the role of information security in this process remains largely unknown, indicating a need for further exploration. We have observed a common tendency for organizations to overlook information security criteria when selecting vendors. For instance, Bonga reports that 74% believe third-party vendor selection overlooks potential key risks. Meanwhile, a 2019 study by HelpNet Security suggests that third-party network risks are driving critical business decisions. Therefore, we aim to investigate whether information security failures, specifically data breaches, drive organizations to change vendors and, if so, how this change occurs. Our research framework explores whether data breaches drive hospitals to replace EMRS vendors, and, if so, we further investigate the types and number of vendors involved in such replacements. Moving on to our literature review, vendor selection is a focal point in operations management research. Past studies have identified factors such as procedural rationality, economies of scale, and supplier ties influencing companies' decisions in selecting third-party vendors. However, the impact of information security on vendor selection in the era of big data remains unknown, suggesting a direction for further exploration. Recent OM research has started to pay more attention to the topic of digital confidentiality, yet studies in this area are still limited. Our research contributes to addressing this gap, as acknowledged by Massimino et al. In their 2018 literature review, stating that digital confidentiality has received vastly less research attention from operations and supply chain management scholars than cost, quality, flexibility, delivery, and innovation. Next, I present our theoretical framework and hypotheses section. We employ a attention-based view to analyze the impact of data breaches on firms' vendor selection. ABV describes how decision-makers allocate their attention to an extensive portfolio of problems confronting them. This theory emphasizes that decision-makers have limited attention capacity and cannot focus on all aspects. Problems from different domains compete for their attention, and what decision-makers focus on depends on the specific situation. Additionally, as attention shifts in different contexts, decision-makers' choices follow the direction of their attention. Within an ABV framework, we first explore whether hospitals replace vendors after a data breach. Under normal operating conditions, attention is primarily focused on aspects around their main responsibility to provide high returns to shareholders, such as cost. However, this focus changes with the occurrence of data breaches. After a data breach, hospitals increase their focus on information security, and according to ABV, their subsequent behavior tends to align with this direction, aiming to enhance information security. The selection of EMRS vendors is crucial for information security, and one effective way to improve it is by collaborating with more secure EMRS vendors. Accordingly, we propose our first hypothesis: data breaches are positively associated with the replacement of electronic medical records system vendors. Next, we want to explore how hospitals, in the process of replacement, choose vendors. This strategy involves two aspects: what kind of vendors to choose, and how many vendors to choose. From an ABV perspective, a strong focus on security prompts decision-makers to prefer candidates who perform well in information security. However, determining the security level of candidates poses a challenge. A potential clue is whether a vendor is a star, as star vendors have a strong reputation, strict obligations to clients, and accumulate sufficient security-related experience from a large client base. Therefore, we propose our hypothesis: data breaches are positively associated with the selection of star-rated EMRS vendors. Furthermore, we focus on the number of vendors a hospital chooses. EMRS consists of multiple modules that can be outsourced to multiple vendors or to a single vendor. The current trend is a preference for the best-of-breed multiple sourcing strategy. However, according to ABV, a strong focus on security prompts makers to lean towards candidates who excel in information security. Adopting a multi-sourcing strategy transforms more external parties into privileged insiders, increasing security monitoring and coordination burdens. Consequently, we predict that data breaches will trend hospitals towards further single sourcing, as this strategy is easier to manage in terms of security. Now, let's move on to our empirical methodology. Our vendor selection and control variable data come from HIMSS, while data breach data comes from PRC and ITRC. To minimize endogeneity, we focus only on external data breaches. After merging data from all sources, our final sample includes 60,793 observations from 5,508 unique U.S. hospitals, covering a 12-year period from 2006 to 2017 and involving a total of 566 data breach incidents. Additionally, as EMRS is an IT application environment consisting of modules, we focus on the 5 most commonly adopted EMRS modules defined by HIMSS, CDR, CDSS, CPOE, OE, and PD. The results variables of interest include threefold. The first is replacement. It is a binary variable equal to 1 if the hospital replaces its vendor in any of the EMRS modules in a certain year, and 0 otherwise. The second is star switch. This is a binary variable equal to 1 if a hospital switches to a star vendor in any of the EMRS modules in a certain year, and 0 otherwise. The third is single sourcing. This is a binary variable equal to 1 if a hospital's distance from a single sourcing configuration is reduced compared to the previous year, and 0 otherwise. Table 1 provides examples of the measurements for these outcome variables. Replacement is coded as 1 if there is any change in vendors compared to the previous year. If this change further involves a shift to a star vendor, then star switch is coded as 1. Additionally, if the distance to a single sourcing configuration decreases, single sourcing is coded as 1. Furthermore, it is highlighted that star switch or single sourcing configuration can only be 1 if replacement is 1. We employ a combination of the fixed effect difference in differences and coarsened exact matching approach as our identification strategy. Equation 1 outlines the model used, and in CEM, we utilize K-to-K matching, incorporating all continuous control variables as covariates for matching. The L1 value, representing the overall distance in covariate space before and after matching, decreases from 0.905 to 0.611 after CEM, indicating the effectiveness of the matching process. Table 3 presents the results of our baseline analysis. Regardless of whether controls are introduced into the model, the coefficients of the pseudo-double difference terms are positive and significant for each outcome variable. These results suggest that hospitals replace vendors, switch to star vendors, and migrate towards single sourcing configurations after experiencing a data breach. However, for the DID results to be persuasive, it is crucial to verify the parallel trends assumption. To test this assumption, we conduct a parallel trends test using the model outlined in equation 2. Figure 2 demonstrates that, in the pre-treatment years, the point estimates of beta are distributed around the zero horizontal line, providing no evidence of significant differences in pre-trends between the treatment and control hospitals. Furthermore, we performed a series of robustness tests. Firstly, we employed an alternative matching approach, entropy balancing matching, and secondly, to address concerns about certain modules being less likely to be replaced, we conducted additional analyses at the module level. Thirdly, we substituted the fixed effect logit model with a fixed effect LPM. All results remained consistent with the baseline, further supporting the robustness of our findings. In the post-hoc investigation section, we explored contingency factors. First, we investigated how the duration of client-vendor relationships influence the relationship between data breaches and vendor replacement. We predicted that the impact of data breaches on A. EMRS vendor replacement, B. Star EMRS vendor switch, or C. EMRS single sourcing migration would weaken as the client vendor relationship duration increases. Second, we examined the impact of hospital system size. Hospitals within large healthcare systems are more locked into existing relationships, making it harder to replace vendors. Thus, we hypothesized that the impact of data breaches on A. EMRS vendor replacement, B. EMRS vendor switch, or C. EMRS single sourcing migration would weaken as hospital system size increases. Table 5 presents the relevant results. The coefficients of the interaction terms between the pseudo-double difference and the moderators in the DID regressions for the duration are shown in columns 1, 2, 3. The negative and significant coefficients indicate that the impact of data breaches on vendor replacement, vendor switch, and single sourcing migration weakens with the increasing duration of the client-vendor relationship. Columns 4, 2, 6 show similar results for the moderation effect of hospital system size. The simultaneous consideration of both moderators is presented in columns 7, 2, 9, provide additional robustness to our research results. In the same model, we simultaneously considered the two aforementioned moderators to evaluate their respective impacts. The results in columns 7, 2, 9 of Table 5 are consistent with previous findings, providing additional support for the robustness of our research result. For a clearer interpretation of these findings, we employed marginal effect plots in Panel A of Figure 4 to illustrate the moderation effects mentioned above. Panel A illustrates that, in the presence of long-term relationships, the positive marginal effects of data breaches on vendor replacement, vendor switch, or single sourcing migration are weakened. This graphical representation aligns with our regression model findings and provides evidence supporting the moderation effect of client-vendor relationship duration on the main effects. Additionally, Panel B of Figure 4 indicates that the large hospital system size weakens the positive marginal effects of data breaches on vendor replacement, vendor switch, and single sourcing migration. This graphical representation is consistent with the results obtained from the regression models, providing evidence of the weakening moderation effects of hospital system size on the main effects. Lastly, we explored the impact of data breach scale on the results. We define data breach scale as the number of compromised records in a data breach. Larger scale data breaches tend to attract more attention to information security. We expected a more pronounced relationship between data breaches and vendor selection following large-scale data breaches. Furthermore, we anticipated that the impact of a data breach on vendor replacement would be short-term rather than long-term. The results presented in Table 6 offer insights into these expectations. Firstly, the impact of data breaches on hospital vendor replacement depends on the breach scale, appearing for breach scales below approximately 1,000. Additionally, this effect is short-term, materializing in the year of the data breach, prompting hospitals to promptly replace vendors, and disappearing in the following year. Secondly, similar to vendor replacement, the impact of data breaches on hospitals switched to vendors is also contingent upon breach scale and exhibits a short-term nature. The effect disappears for breach scales below approximately 10,000, manifesting immediately in the breach year and subsequently fading away. Moreover, we observed that the impact of data breaches driving hospitals to migrate toward a single sourcing configuration is also dependent on breach scale and displays a short-term nature. Specifically, the effect weakens when the breach scale is less than 1,000 or after the breach year. At last, we discuss the implications of the paper. In conclusion, our study has significant implications. Firstly, it makes a substantial contribution to existing literature on vendor selection by identifying information security as a crucial criterion. While previous research focused on criteria as cost, vendor efficiency, cooperation history, and professional competence, the importance of information security was largely overlooked. Secondly, our study contributes to the field of operations management by exploring the impact of information security failures on supply chain collaboration. Despite information security being widely recognized as a critical concern in supply chain management, empirical research on this topic within the OM field is lacking. Our study fills this research gap by providing empirical evidence on the impact of information security failures on supply chain collaboration. Thirdly, the study contributes to the AB literature by examining how organizations' negative performance, Specifically, data breaches serve as stimuli to divert attention and drive strategic changes in the supply chain context. Lastly, the study contributes to the OM literature on multi-sourcing by identifying information security as a crucial determinant of organization sourcing decisions, filling a research gap in the limited understanding of the factors that influence multi-sourcing.